Hello and welcome to a brand new series which I'm going to be starting, which is making video games with Processing JS right here on good old Khan Academy. Now I'm making this video series assuming that you all at home already have watched the Khan Academy series on computer programming. If you haven't, then I'd suggest not to take it because you literally have no idea what I'm talking about. So just take the Khan Academy series on Processing JS. It should take you only a few weeks, even if you give like half an hour a day. It'll take you less than a month, and then just come back to this video, I guess. I mean, it shouldn't be too hard, although this course is popular, so I'm assuming at least some of you guys have taken it. So without further ado, today I'm going to show you a video game I'm making called a tutorial on a video game I'm making called Need for Speed, and I'm gonna be showing you step by step how I made the game design, and what the rules and functionality. So as you can see here right now, now going forward, assuming you already know what Processing JS is or you've already taken the course, let's go. So now, first of all, for this program, what do I need to do? Every video game, in the end, just has objects that are performing functions. Be it a shooter game with one sprite, or like in Scratch, right? One sprite or object shooting bullets at an enemy, or a racing game like what we're making here. Each separate character is an object, and each object though has some properties that define what that object is and distinguish it from other objects. So let's get started by creating the two red objects for level 1 of this game. Sorry? Who knows, without him I don't know what I do. And boom. So you can see here I've already created three objects actually that I'll be needing to make, because those are going to be the three different players or in the game, as in the end each object is a player. The red boat, the green boat, and the cyan boat. The reason it's not blue boat is because the background is going to be blue and the blue boat will be kind of invisible, so that's why we're not doing it. So let's just begin by defining the red boat properties. So for obviously though, in any video game, one thing that we define the objects are is by what their position or initial position is. Like in Pac-Man, how Pac-Man himself is defined first in the center at that position where he can right opposite from the ghost. That is what their initial position is. And similarly here, right now I'm defining the initial position, the initial X position of the red boat, as this is a 400 by 400 single quadrant coordinate plane over here. So what I'm saying though is that this boat's initial position will be placed around 100 pixels to the right, and then let me define the second property, which is initial Y position, which is slightly off by 92, meaning that the red boat's initial position will be 100 across and 92 up, so should be roughly around this region. Now though, if we just have a photo of a boat just sitting there in its initial position and not doing anything, no one would want to play the game, and it would make for some mediocre wallpaper at best. So that is why I want to describe another feature that of this boat object, which is its forward speed, which I'm actually going to assign a random value from 1 to 3 just to keep it interesting. So now this is saying that when the boat starts, it can either go between these speeds, and it can change its position by only this many pixels for a given time, or else and nothing beyond. So this defines for the boat object how fast it's going, and then obviously different boat objects will have different speed, kind of like how different people right now have different speed. For example, like if you're comparing me, like if this speed compare my speed to Usain Bolt's speed, the Usain Bolt speed object will have a little bit of a higher speed than I would. So same situation here. But now if the boat only goes forward, that isn't really how racing works. So you have to go, whenever you're in any type of race or racing game, or even Galaga, you realize though that the sprite or object that you're working on can go multiple directions or travel in multiple directions, and that is what I'm doing here. So we have forward speed random 1,3, and then backward speed, which is the speed that will go when we want this boat to go backwards, which is -1, -3. again. So that means the reason I made this negative is because it could decelerate or go back by this many pixels for a given amount of time. And now, since I wanted to add four directional control for this boat, which will only be for this boat, as it is a the boat that is controlled by the user. The boat controlled by the user. The other boats aren't. So now we'll do upward speed, which is basically how much in the y-axis. This is for x-axis. This means going forward by 1 pixels, between 1 to 3 pixels in the x-axis, or backwards, right? Upward speed is positive, going up by this many, and downward speed is this many. So let me just do that to show you here. Upward speed is going to be the same as forward speed, but it'll be in a different direction, which is why they call it would be the vector quantity. They have the same magnitude or similar, same defined magnitude, but it's happening in a different direction. And then last but not least, downward speed. Over here, right there. And this defines the object for the red boat. Now I'll get to the green and cyan boat later, but first let me create the red boat itself. So if we just come over here, right. So for the red boat itself, I'm gonna define it with this color, which means that it's a red in color. As you can see here on the RGB scale, red is full and the others are empty because, well, it's a red boat. And then I just have to use two simple coordinates to define what the red boat looks like. First though is rect, and then we call on the red boat object, and then we say, hey, create a rectangles at the x coordinate of the red boat's initial x position over here. Now obviously this thing's complaining because I haven't filled out all the necessary form. And now the same for the y position. So red boat dot initial y position. So now what we could see though is that now the computer, the document object model is gonna interpret this rectangle object here and give it the coordinates that are defined here on the canvas, which are x and y. And then we just give it the size, meaning that I want it to be this many pixels long and this many pixels tall. And as you can see here, there's a red rectangle right over there. So I will continue but this doesn't really look like a boat. This looks like a lonely rectangle. So for it to be a boat, we'll have to add a bit more of a shape to it, which is why we're going to use the arc property here. Arc, as you already know from watching the course, can define any circular object or any curve that you want to define as a start and start point, and you give its dimensions as well. So if we do red boat dot initial x position plus 24, that means it's below the, I know it's plus, but it actually means it's below this rectangle by that many pixels, so that there's no overlap. And then red boat dot initial y position plus 12 over here. Then we just define the dimensions for this. So this is the width, the height. Now we're going to define the width, the height, and what points it should stop at. So 46, -1. This though I did mainly from like trial and error with the editor. It's extremely helpful editor, so that's why. And now for some reason the boat is not showing the red arc. It's odd because I figured it out. Wait, one second. Why is it not showing? That's weird. Okay, let me try that again. Someone just directly copy paste again. There you go. Huh, that's weird. I must have made some error. I promise this is my code only. I'm just rewriting it for your guys' understanding. But yes, this is a boat-ish. I mean, pixel era boat. I mean, come on, guys. You have to give me credit. I mean, this is based off of old school games, and those guys basically had zero functionality. But I digress. Okay. And here we have defined the red boat object. Now let's start with the other boats as well. Starting with the green. As the green boat is not a user controlled boat, it will have simpler code being involved in it. So obviously I have initial X position to be 100. And the forward speed of random, which is slightly less than the red boat, which is to give the red boat a chance, like a higher chance of winning. Otherwise, not a lot of rage quitters would be cursing at me. Obviously, I also rage quit. I understand their pain, so that's why I'm giving this guy a little bit of a fighting chance. Oh, sorry, I forgot to put these as negative. And now for this, the initial wipe, it's obviously going to start from the same X position, the same way race cars are put directly together horizontally. But obviously it's going to be a bit lower. So the initial Y position, I'm going to place at, let's say, 102. Just a bit below the red. Obviously if it's a bit less, I can easily change it. It shouldn't be much fun. Let me just save this and we continue. Now, obviously I haven't divided it upward and downward, and that's because since it's an auto controlled boat, it'll just keep on going forward or backward even. In fact, actually we don't even need the backwards, since it's not got the same intelligence as our red boat. It won't be able to do the same maneuvers as the user control boat. It'll literally just be going forward, which again gives the user a bit of an edge. And now if we have to define the actual red boat itself. Oh right, I forgot to mention one thing. We're gonna have to keep this under the draw function over here. The function, and this is a program defined function that is executed by the processing library to draw an image again and again, as you would have known if you've already watched this tutorial video, but again for clarity's sake. So now obviously I have to define a background too for this boat for the first level, which is going to be on boats. The second level is going to be on cars, and the final one I'm actually hoping to include planes. So obviously it's going red because it was red. That's the default value, and that makes our boat look bad. But luckily water is in red, which would be really freaky. So we can define it as let's give it that color, a sky blue color, and now that looks like a proper boat. So if you want to add more stuff to the background, you could define an ellipse here. First, let me fill it as yellow. So 255 by 255, meaning you're mixing together red and green at full to get yellow here, and then ellipse. This one I'm just doing for testing. So the coordinates are about right, but I'll make this thing a little bit bigger, and let me just readjust it. So we got a little sun here. And then let me in fact change the position of the boat a bit too. You can see here, since they're all perfectly in sync, the initial coordinate red position for both the arc and the red, we can treat this boat as one object, so it doesn't create much of a hassle in changing its position. So yeah, we'll keep it around there. Which means I also have to change my green boat, but it won't matter much. This IDE is extremely helpful in that regard. So now let me just copy the paste for the code for the cyan boat, since it'll be again very similar. So I think I'll make this a blue boat since the background is all cyan. So yeah, let me just in here. Now the exact similar functionality as the exact same properties I should say as the green boat. So over here, and then I think I'll change this around a bit. I mean, right now just let me define each boat for itself. So I'll just comment this out. So this is code for the background canvas, which is a little backdrop object here just for scenery purposes. And this here us actually using the red boat's properties and giving it a physical form, manifesting a physical form. Always put these comments around here as they'll make much less of a headache for you. Not user, sorry. Program control boat. We'll be adding in another user control boat, but I will do it at a later stage once we've set this game up a bit better. Then, now let's define the green boat. Fill the RGB, so then this one will be doing full. As you can see here, a nice Hulk green boat. Now we're using the green boat object and its properties on initial X position, and then we're going to do green boat initial Y position 40, and then we're just going to keep the dimensions the same as the red boat. Which again, for some reason, this thing isn't showing up again. Why not? Why now? Just strange, because there should be a green arc over here. Wait, let me just... Okay, let me just redefine this code over here. It should be working, and there should be a green arc showing up here. A rectangle at least showing up here. Is it because of the... Hold on. I think it might be because of... Don't know why. Okay, that's really strange. Now let me just continue defining the arc for this boat here, and then I'll just get back to that problem. But generally, this is how you're gonna want to code it over here and here. Okay, now I get why. Let me just put this thing down a bit. Oh, no, later. I mean, okay. Where to go? Okay. Green boat dot. Some reason it can't identify the green boat object. Wait, let me just throw this down a bit. See, this type of debugging problems do occur in do occur while you're coding, which is why I'm not bleeding this part. I'm showing you how sometimes you debug whatever something isn't working. So right now over here, the problem is that it seems to be able to doesn't seem to be able to read the green boat object. That's why it was not able to render these. Well, it was able to for red boat. So we'll have to find out why. Initial boat. Let's just change this. One way of testing is, see, it's not able to see this for some reason. Okay, so this is a problem I'll have to fix, which I will for the next tutorial, but till then, you guys just remember the code for here as well, and then I'll see you in the next one. Goodbye and peace, and just try at least the first part for defining the red boat, and then tomorrow we'll finish up the other two, and I'll show you how to make them move as well. So for now, goodbye and thanks for watching.